Hi guys, this is Sathvik, an alumnus of HPCE CSC. So I am at present working in a Big Four as a business analyst. So I've been learning machine learning since my first year of college, so I believe. So I'm pretty much an intermediate in machine learning. So I can share you my peace of mind so that you can go through this and you can learn, you can get something out of it. And if you are absolute beginners, yes, I can give you an opening introduction on how it began. And if you guys are intermediate like me, please don't disturb the others. Please do listen to what I'm telling, and you can post your questions post the session. So, yeah, if you guys are ready with your book, your pen, and a water bottle, we can very well go with the session. So I hope it is clear for you now. So if it is clear for you, we can actually proceed. And from the comments, I see that it's perfect. So yeah, I'm going with it. So, what is machine learning, guys? Machine learning is a topic where a machine learns by itself and it gives an output with a human intervention. But that is only in the initial phase. So, as in when a machine sees a lot of data, it learns by itself and it goes through various process before it can give a meaningful output. So, machine learning involves a lot of human training, like how you train your pet or train your kids. So, it involves a lot of process in tuning the model itself, and with that processing you'll get different outputs from the computer or your machine or any kind of cyber physical thing. So yeah, that's pretty much it. So yeah, so we're gonna cover the space of AI, the space of machine learning, and we're gonna learn what machine learning comprises of, and we're gonna learn how to build a predictive model. And I pretty much believe that we can go with the coding hands-on session, but let us see if time permits. So yeah, so machine learning pretty much began in recent times in 1970s. But before that, we see how the Industrial Revolution began. Revolution began first initially in 1760s with the introduction of water and steam systems by the British Empire. So this Industrial Revolution has revolutionized the technology. It started using technology like using steam and water when we were using stones for calculation and stuff like that. And post that, we wanted to do something with our lives to build lot, to build more, and to make more money out of it and make lives easy for a lot of people. So that is when we had electricity in our life in industry 2.0. So that was pretty much during 1840. And post that, it was all about information technology. And before information technology, we had one interesting event happening in our life. We were not born, obviously, but during those times we had wars. So interestingly, during the industrial 2.0, Great Britain, US, and Germany were the forefront drivers in technological revolution in 1840. So they were pretty much the big massive powers in the world, and that is why we had wars. And in industrial 3.0, we learned how computers got connected to each other, and we can see how internet has paved through in pretty much everything in from industrial 3.0 until now. And internet is everything, guys. It has made us connect through a lot of things like in Chennai floods, and even now during quarantine we are like miles apart now. We can be kilometers apart now, but we're connected now. So that is the power of internet. And what if we give the power of internet to machines to do its task by itself after a meticulous training by us? That is what we're going to see with the technological evolution of artificial intelligence. So artificial intelligence plays a great role in industrial 4.0. Right? So if this time is doing something like working remotely or setting up manufacturing industries by itself. And if we do something out of this time in quarantine, if you're going to produce a lot of products during this time, it is because we have automation in place, and that automation came into place because of cyber physical systems. And it is not entirely automated, like the machine does everything by itself. It needs human intervention now. But industry 4.0 focuses on giving everything in the hands of the computer. So if we are gonna be in adventuring into industry 4.0, we pretty much should be venturing in artificial intelligence, right? And I'm pretty sure that you guys are with your notebooks. So please make a note of this, because this has a great impact on what you're going to do next after this session. Because this is going to give you clear insights on how you can function post this event. So yeah, I'll give you 2 minutes time so that if people who've not gotten their notebooks, they can do it. So yeah, I believe you have your notebooks now. So what is artificial intelligence, guys? Artificial intelligence is pretty much a lot of things. It involves machine learning. Machine learning is what we are going to cover now. So let me go back to that later. What is natural language processing? Natural language processing is how a computer can communicate to another computer using machine language. So it involves a lot of things. It is like how your computer understands your program and processes your program using TOC. So it like theory of computation was the base of computers, guys. So like using artificial intelligence and NLP, compute your cyber physical systems such as your two two machines in an industrial floor can communicate. So you can pretty much go with the implementation part of it. And expert systems is what we have had age old time, guys, because expert system is something which doesn't require a constant training or anything, because you would have functioned in linear programming such as if yes statement, if else statement. So yeah. And your speech, when it comes to speech, it is speech to text or voice to text, or text to speech. And speech to text is pretty much what your YouTube translate does it right now. If you have a CC button, then you can right now press your CC button to see speech to text. It gives obviously junk values because it is trained with a lot of things, but each and everybody person's accent is different. Training is really tedious, but that is an example of speech to text. And for text to speech, you have your Alexa, Cortana, and you have your Siri, you have your Google Assistant to go with that. And vision, image recognition, and vision. Uh, that is one other example of artificial intelligence which uses neural networks there. So image recognition is something where you identify a cat or a dog, and you don't know how many times it comes right before you actually do it right. And planning is something where it comes in a supply chain, right? Supply chain is where an industry knows how to plan for their inventory, where industry knows how to go with their industrial purchases or how to market their demand. So yeah. And robotics is pretty much in its intermediate stages now. It is not uh completely utilized now, but robotics is one thing where artificial intelligence is going to survive and thrive. So that is pretty much of reinforcement learning. So yeah, we go by the definition: ability of a machine to imitate intelligent human behavior. So artificial intelligence, as the name suggests, it is going to be intelligent, but how intelligent, that is going to lie in the hands of the person who's going to create an artificial intelligence device. And right now, you pretty much know what our industries use AI. We have Amazon, which is one of the biggest multinational corporations, and Google, which is pretty much everywhere. You have your Google Pay right now. Like when during these times when you have to order food and when you have to donate to PM Care funds, you have your Google Pay. And for manufacturing, it is pretty much there, guys. Manufacturing industries, in one example near our college, we have Hyundai, where they use robots for automation. And in banking, you have these insurance bots coming up recently, and in banking, a lot of things are there, guys. AI is used in places where you can find somebody who's doing fraudulent activities in your accounts, or somebody who's doing illegal transactions, and all that is monitored using artificial intelligence. So yeah, so I believe you've grasped all of this, and I believe you've plotted somewhere over about this. So we'll go to the next slide. So yeah, so we are going to discuss about something called as long-term memory in human beings. Long-term memory refers to storage of information over an extended period. If you can remember something that happened more than just. So what we are trying to tell is we human beings have something called as long-term memory in us, where when we were kids, we didn't know how to walk, we didn't know how to crawl, but we did it so many times over and over and over again, because we wanted to learn that really well, that we didn't need any human intervention after that to teach us how we have to do that. So that is some kind of long term memory. So like when we were kids, we initially kids used to recognize numbers, we used to recognize colors, we used to recognize patterns, and all these are known as long term memory. So this happens due to a lot of processing, or a lot of examples that we see in our real life. So yeah, so we have types of memories, which are explicit memory and implicit memory. Explicit memory is something that requires that doesn't require your conscious effort, and implicit memory is something that requires your conscious effort. Explicit memory is something known as like, see, when you walk, when you were a kid, you tried to walk, you did it a lot of times, you did it a couple million times, and after a time you are unconsciously walking. You need not see what you're stepping on, you do not see what is near you, you don't see that, you just go when you want to do it fast. So that resides in the explicit part of your memory, procedural part of your memory. And in implicit memory, in something such as semantic memory, that is something like, we pretty much didn't know what corona is until last December, and post that we learned what corona is, we learned what its situations are, we learned how to prevent it, and all that comes under semantic memory then. So this does with the shorter memory conditioning, this does with the memory conditioning, where you learn a lot with a contextual basis. And episodic memory is something where we learn from events. So after today, if somebody is going to ask you what long-term memories are, you're going to remember that so and so guy had come, he taught us over online about episodic memory. So that itself is one example of an episodic memory. Or you can remember Dhoni hitting that winning six. So yeah, so that is pretty much a big episodic memory for all of us. So yeah, so you can actually follow the link here. It pretty much can explain you in detail. So post this, guys, we are going to the next section. So we're gonna understand the crux of artificial intelligence. So artificial intelligence is a space where a computer tends to behave like a human being with human intervention. So artificial intelligence has a lot of parts, guys. I'm not going to the other parts of artificial intelligence today, but we are going to see pretty much about machine learning and the crux of machine learning. And I don't know if time permits that we go into depth of deep learning, but we are pretty much going into machine learning today, guys. So yeah, machine learning is full of mathematics, it's full of statistics, it's full of probability. And if you guys are really good at statistics, and if you're good at probabilities, then this is for you guys. This is really for you. So a lot of people have been asking me about the uh, the safety and security guidelines of artificial intelligence. So this can pretty much tell you, if you're going to train your model bad, it is never harmful, guys. It is always nice. It is always good. But if you're going to train it in a wonderful way, if you're going to train it in a way where it can do wonders like Google Assistant or Alexa, so then we are in trouble. Then we are in trouble because they hear everything, they store their data, they do training with that. So knowingly or unknowingly, you are giving away your information. So if it's harmful or if it's not harmful, it lies in your hands. It lies to your judgment. I'm not giving any judgment here. So yeah. So these are poor examples of artificial intelligence, and this pretty much answers if artificial intelligence is harmful. I'm not telling anything, but these are so-called inspirational quotes generated by artificial intelligence. You can see new ideas have been invented to be destroyed. Number two, whenever you're dead, remember to never lie. These are actually not inspirational. If you guys aren't getting it, these are not inspirational, but artificial intelligence thinks it is inspirational. So the way it understands our kind of words and way it takes its words, the place where it understands and the place where we have a symmetry between the understanding should be properly maintained in order to maintain peace between machines and computers. Guys. Seek success but prepare for vegetables. These are not actually quotes. These were generated by computers or artificial intelligence. Keep panicking. This is not inspirational at all. So yeah. So if we can proceed, so we are going to learn about subset of AI. Art machine learning is a subset of AI. It deals with statistics and probability methods because you're gonna make a lot of judgments here, right? Statistics is like it is a conventional method which is being used over hundreds and thousands, hundreds and thousands of years because it was found very useful because people didn't generate a lot of data. A company needed 10 analysts or 20 analysts before the usage of computers where they wanted to audit, where they wanted to see a company's transaction or something like that. But right now we have computers, we have a lot of computing memory, and we have mammoth of choices. We have different laptops, we have different GPUs, we have different RAMs, and we have a lot of things. So we need not worry about computational power. So AI, machine learning, it is taking a lot of jobs in the sense it is making companies' lives easy, people's lives easy, and the job security. I'm not going to answer about that. Let us have it for the later part of the show. And yeah, the difference between general programming and machine learning is that general programming is what you condition a computer literally. So computer won't learn anything there. It is going to direct you. It is like having a signboard in a road. So when you have to go from Keel Park to Annanagar, you have to take right, you have to take like left, and all those will be displayed on the signboard. And that is going to be something your uh, general programming's example. And machine learning is something that understands your query, that knows your query, and it predicts and it gives you an answer. Every time you need not code, you just have to build a model, and the machine learning model will hold the weights for the later part of the show. And when you give in new data, it will give you a predicted output based on your historical data. So say if RCB is going to win Premier League or RCB is going to win Indian Premier League, you need to do a lot of statistical computations, you need to do a lot of machine learning technique, and you need to do a lot of things just to find it is not going to win. But you know that using general programming. But with machine learning, that is really difficult, guys. With machine learning, it can say that it will win. So that is why they still have a team. So yeah. And certain prerequisites for machine learning are statistics, probability, and queuing theory. These two are crux of it, right? Linear algebra, it is really, really important. Calculus is really important. And your basic C++ is much, much important when you go for deep learning. C++ basics will live with you for any kind of algorithms or any kind of adaptation with computers. And most of all, patience is most important, guys. So like I've been learning machine learning for 5 years and it is still evolving, it is still under research. So it's been under research for like last 30 years and it's still evolving. So you can't really master it, and you just can get better with it. That's all. And yeah, if you guys were interested so far, we are getting into the important part of it. So yeah, how is machine learning different to statistics? So statistics is something which is going to give you inferences on the data. Like it can find you outliers, it can find you a regression line, it can find you a basic examples like mean, median, mode. And machine learning pretty much uses a statistic to deliver its results. So machine learning is more like something that holds a lot more than statistics in itself. It holds a lot in its toolkit to do its computations. So yeah. So here there is an example of McKinsey. our competitor, which shows customer churn analysis. Churning is something where people who use Geo in the beginning and after their free offer expired, they came out of Geo. So churning is one such thing. So McKinsey had to deal with one such thing for a telecom example. I'm not sure if it's Geo. So here, statistical analysis states that gives the prediction if the person or if the people who are using it are harmful for churn, or are they more often tend to use it more often than what other people use. So these concentric lines or these isobar graphs you see, they were machine learning implementation, which said about the risk of using machine learning. I mean, for using the telecom industry SIM cards or something. And the regression line just gave out a line stating these people are harmful and these people are not. So it doesn't give you a meaning in this example, because telecom industry uses millions and millions of customers and they can't lose half of the customers just like that. So for this purpose, they had gone for an clustering algorithm or churn predicting algorithm, where they had to divide into clusters and they predicted the risk of it. So yeah. So guys, machine learning algorithms and statistical algorithms are very different in the sense like uh, statistics is a part of machine learning, but machine learning isn't a part of statistics. So you can take it that way. So when I build a lot of models with my 16 GB RAM for millions and millions of data, that is still feasible. But for statistics to chunkize millions and millions of data and give a meaningful insight about a data, it is going to be really hard, guys. You just need a supercomputer. You just need a quantum computer for that purpose. So yeah, this is pretty much the difference between statistics and machine learning. So yeah, these are certain examples of machine learning. So yeah, I'll go with Netflix because we guys are pretty much using Netflix these times in this quarantine time. So how does machine learning influence Netflix? It is going to give you recommendations, guys. It is going to give you horrible recommendations. And the streaming quality with the pricing, with the predicting bandwidth feature, it is going to give you a good quality of pictures or videos by predicting your internet's bandwidth. Say if I have a low bandwidth, bad internet quality, it is going to give me a bad quality of picture, or it is going to enhance certain features and it is going to switch off certain features so that it can match the performance with the other bandwidthing, or it can match their streaming performance. And Facebook is personalizing ads, guys. So I'm not telling that they're stealing your data. I'm not pretty sure of that. But Facebook is pretty much personalizing your ads. They are doing everything for you by knowing everything about you. So it is giving you stupid friend suggestions. It is doing face tagging. And yeah, memories has nothing to do with this, but memories is also a pain in the ass for with Facebook. And Amazon. With Amazon, we have pretty much something called as recommendation system. Amazon recommends a lot of products to us, where when we get a pen, it tells us to get an eraser. I mean, we don't get a pen on Amazon, but just for an example. And ad delivery, yeah, with the kind of products we buy, it tends to give us the ads based on that. And all that is possible because of their computations and their classification algorithms on what kind of customers we are and what kind of products we buy. And Amazon is able to deliver your products from one part of the country to another part of the country, or even different countries, because of their wonderful supply chain algorithm. So it is all possible because of the optimal research. So it is wonderful. And Google, I don't need to tell you guys, you pretty much know about it. Google does everything for you every day. It finds the news appropriate for you, and it gives you good navigation when you go from your office to your house. And it does spam detection. It puts it directly to your spam folder when you get stupid mail. And your Google Assistant talks to you, it listens to you, and at times it plays with you too. So yeah. So, and another feature is Google Ads. Google AdSense is a wonderful thing where it is going to give you wonderful ads based on your search. They're not collecting data. They are collecting data, but they're giving you meaningful ads too. So yeah. So we're pretty much getting into the crux of machine learning. So what is machine learning, guys? Machine learning is a process where you give tons and tons of data for a machine to get insights from it and to learn something from it and have its own knowledge base. And it is going to use that knowledge to make predictions with your future data. So say if a person is going to what example do we give for machine learning here? Or say Google's ads. Google uses a system called federated learning, where it has different sectors for different nodes. It collects data from that position, and with that data, it is going to make a knowledge, and it is going to give you. It is going to make a management decisions based off that. So say you've typed some 100 words with one paragraph, uh, stating something, some quote or something. Google takes that, it goes to the knowledge base of Google saying this guy is sending this. So it asks its profession, it asks its data, its knowledge base, if it is a good thing or if it's a bad thing, if it's a harmful content or if it's a good content. And if the knowledge base says yes, it is a good content, then it won't filter it. If it is not a good content, then Google filters it. So this thing, for Google to work in such a way, it needs tons and tons of data, and with that data, for each chunk of data, it is going to train its model again and again and again to make it better and better, and at last the best. So Google is at its best right now. Sorry, Apple fans. And machine learning framework. So what do we do in machine learning? So basically, we learned about data collection. We learned about how companies use data collection for machine learning. And the data collection here in our project, if you are going to predict something like a heart rate or heart disease, or sometimes something like Alzheimer's, you have to collect tons and tons of data, image data, signal data, and all that. And you have to make a summary of the data, and you have to understand the data first. So there are different types of data. So you have a type called quantitative data, qualitative data, and for each type of data you have to do different kinds of processing. And I'm just giving you one example here. This was my project back then. So I had this project called the Twitter sentiment analysis during my second year or something. So where it predicted US elections campaign, and it told if it is positive, negative, or neutral. So the Twitter sentiment analysis crawls through the Twitter. It gets the tweets from the people, and it stores its data. It cleans its data, and I mean, actually, I cleanse the data, and post that cleaning, you have to split your data into test and train split. Test, train, validation split. Train split is going to train your model. Test split is going to check if the values are right after the model building. And your validation split is going to check your accuracy. It is going to validate your model. It is going to say, if I've trained with 1000 data points, if I'm going to have 500 data points for training, 200 data points for validation, and 300 data points for testing, 500 data points will get inside the ML algorithm. It will train. So so something like, if Apple is really Apple, if an object is an apple, so you have colors of apple stating red, blue, green in your features. You have its size in diameter of about 3 centimeter or something. I mean, not 3 centimeters. Okay, some size. You have its texture, smooth or something like that. So if you will have those features, and based on those features, your algorithm will predict if the object is really an apple. So with that algorithm, with that model, your validation data with certain data points of, say, blue color, and rugged texture and 1 meter size, when it goes to the model, it checks with the model train it checks with the data trained in the model, or it checks with the values in the model for the data trained, and it gives an output if it is an apple or not. So this works in that way, and you can measure its performance using certain metrics such as evaluation metrics, or you have something called true false, true positives, true negatives, recall, precision, and all that. So based on all these metrics, you're going to define a machine learning's accuracy or machine learning's performance. So yeah, we'll come back to this later. We'll go to the main crux of the topic. So these are the types of machine learning, guys. So we have something called as supervised learning. We have something called reinforcement learning. We have something called unsupervised learning. So unsupervised learning is a part where you don't have a target variable saying you're not telling if it is an apple or not to the data set, but the machine learning model will find some kind of relations between the data, and it will bring in a feature saying these are blue colored, these are white colored, these are yellow color or something. It is going to differentiate the data. And supervised learning is something where I tell the data that red color, smooth texture, and 3 centimeters in diameter, 3 centimeters in radius is going to be your apple. So supervised learning will know these features. It will store these features and say, okay, this is how I'm going to predict apple. And reinforcement learning is something where a computer, you just build a model, you just have a model. It is going to take its own data. It is going to take its own rewards. It is going to train itself in future to betterment. So all these real-time decision, all these reinforcement learning tasks are most of them in research right now. These robotics and all these things use pretty much of reinforcement learning. So AlphaGo, chess, and all these games are pretty much being played using reinforcement learning with a computer. So yeah, I think I've covered the types of machine learning, and I quickly give you to 10 seconds or 20 seconds to take a note of all these topics, guys. So yeah, I think you guys have taken it down. If you have taken it down, please comment, guys. Okay, I'm not able to see any comment. Okay, so in we are going with machine learning algorithm. So what is a machine learning algorithm? Machine learning algorithm, as I told you, it is going to train with your historical data, and it is going to predict with the new data coming in. So one example for that is when you do spam filtering. So in spam filtering, you know what kind of text someone is going to send you. If it's spam, it'll come like offer, bonanza, and all those words. So you're gonna give all those words with a weightage saying it is going to be spam. So with more and more of data, more and more of historical data, it is going to have more weights for the prediction. And with prediction weights, you're going to predict your unseen data. Your model should always be targeted for future values than with the present values. So say if you're going to predict some disease, like cancer or something, you're building a predictive model for cancer. So you have various features, guys. So with all those features, you're gonna compare it, you're gonna make a prediction, you're gonna give a probability sign, you're gonna give a metric where you train your model. And if I'm a person who has some kind of issue, and if a doctor has to check with all my cases, if he needs some assistance with checking the disease, he just will have to enter those values, and he will have to get the prediction out of it if it's cancer or not. So yeah, so this is pretty much how machine learning algorithms work. You are focusing on the future data than on the present data. So machine learning algorithms are of three types, guys. They are algebraic models, they are probabilistic models, and tree models. So probabilistic models are more conditional, in the meaning. So say you're gonna predict if it's going to rain today. So you have a lot of features. So you're gonna take in a lot of factors into account, like saying yesterday's weather, day before yesterday's weather. You're gonna take the historical data and you're going to take in conditions where the last time it rained, where the last time it was sunny. So all those examples you're going to take to predict it. So predicting pretty much involves probability, guys. So probability and queuing theory should be your go-to subject when you look into machine. And tree structure, it is going to classify if somebody it's going to find it is another predicting algorithm which goes tree wise, so it branches. And if you guys are familiar with data structures, it is a tree structure where you have a node, you have leaf, and it branches with one condition to the another. So tree structure works like that. And algebraic models are more like linear algebra equations or statistical equations we use in linear algebra. So here the one we see y is equal to mx plus b is a condition of a line. So yeah, this is going to be a regression line. So we'll cover about that later. So we are going to start with unsupervised learning. One second, guys. So yeah, unsupervised learning is a task of gaining meaningful output, meaning getting relationships out of data points where you find associations between the data, or where you're gonna group a particular chunk of data. Meaning, when you're gonna go for something like an association rule mining, you're gonna find the associations between the data. So what kind of associations can we go for? We can take the Amazon example. If you're gonna buy a pen drive, the next it is going to show you is a hard disk, because those data points from their supply catalog or from their sales catalog, they find relationships between the customers who buy pen drive also buy hard disk. So that is going to be the support and weight confidence, where they're going to like find patterns in data. So patterns like that is going to be really interesting to see. We are going to see few good examples. And the other example called clustering. Clustering is something where we group a class of data. So say we do something based on shopping power. So based on the age category, certain people tend to buy a lot of things more. So if we are adults, we tend to buy we tend to buy Netflix accounts. If we are kids, okay, if we are kids, what are we gonna buy? We're gonna buy toys most precisely. And if we are gonna be middle-aged guy who is trying for his career, we probably will look into courses like how we are doing right now. So yeah, so you can make that associations, you can make those classifications, you can make those clustering, you can make those groups. Data is everything, guys. If you gain the data, you can pretty much you can pretty much do all kinds of manipulations to the data, and you can find pretty much what you want from the data. But you'll have to involve a lot of learning in that. I got a question from Amrut Naran in YouTube. If we watch a video based on understanding on a pulse, gives the same kind of video, is it? I choose to answer that at the later part of session. So unsupervised learning, as we learned, these are the types of unsupervised learning. We pretty much with the data which has no label, where you have to find, say, take the Apple example again. So you have its shape, you have its color, and you have its texture. So you convert all of that to unified scaled values, and with those scaled values, you're gonna find some summary out of the data, some kind of analytics out of the data. So since you don't know, since the computer doesn't know if it's an apple or not, you're gonna train a computer to find its features and group it separately. So if you have apple, mango, pineapple, it'll find the fruit based on its textures, and it'll find the fruit based on its colors and all that. So you're gonna find mean of certain group, you're gonna find variance of certain group, you're gonna find mode in certain groups. Median, I'm pretty sure that you guys have learned all this from your school: mean, median, variance, standard deviation, skewness, kurtosis. These are really important, guys. If you're getting into machine learning, if you find this thing interesting, and if you're really interested to uh, venture with machine learning or something, these are really important for you guys. And yeah, clustering, as I told you, it was just grouping. So I'll group the data. Again, the pineapple, mangoes, and apples will be grouped based on the clusters, based on the parameters you give. And yeah, based on the features, the computer is going to find patterns in the data. It's going to differentiate them. And association rules, I told you about that. And dimensionality reduction is something where you have 100 features or 1000 features, which is getting reduced to 300 or 400 features, guys. So you find the relations between the data, and you find what is going to affect and what is not going to affect. You're going to drop certain features, you're going to hold to certain features, you're going to be sensitive to certain features. So like the kind of features you give into your model defines your model. So the kind like dimensionality reduction pretty much deals with that. And multi-kernel learning is something which is going to give you, kernel is something like two different dimensions. So take video, take image and take sound in two different things, as two different things. And you combine an image with the audio, it becomes a video, like a motion video or something. So with this example, let us take Netflix. Netflix has its own production house. So what Netflix does more is that after its scenes are coming out of production, it chooses to delete certain scenes. It chooses to append subtitles to certain videos. So it does subtitles on Prime Video and Netflix pretty much do their subtitles with machine learning algorithms such as multiple kernel learning. So you guys, if you're interested in all those stuff, you can actually venture into it, but that is too complex for us right now for an introduction. So we're not adventuring into that. And yeah, so I give you 5 seconds. In unsupervised learning, what is the difference between clustering? Okay, guys, questions at the end of the class. I'll just give you the examples after. Okay, association rule mining. So I think pretty much with the explanation I give you now, I think you'll understand. I'm getting into the crux of association rule mining and the crux of clustering now. So I think you can pretty much understand that. And so yeah, so yeah, Hmm, association rule mining is where this is a classic example. This is a classic example. This is known as market basket analysis that I'm going to teach you. But I'm like let us not uh, let us not have an association saying association rule mining goes to market basket analysis alone. It is used for other things such as census data, protein sequence, cross marketing, catalog designs. It is going to help you with finding your website statistics. It is going to help you finding with your website linking. So all that is done using association rule mining. On Wikipedia, you have these web pages, association rule mined, and it is kept there because based on the analysis, people tend to find the other links, like the links appended to it, more often than not, more often from that. So they append their links to the web page there. So association rule mining works in a lot of ways, but one classic example here that I'm going to give you is going to be with market basket analysis. But I don't want you guys to associate association rule mining with market basket analysis alone. So yeah. So we have one transaction like this association rule mining is done using transaction items and data model, guys. So these transactions, like say in these quarantine times, I go and I get my essentials such as milk, bread, butter. No, these three alone. Milk. These are certain transaction days. Somebody gets it from the shop, and transaction 1, 2, 3, 4, 5 lies there, and these one zeros represent if a person buys it or not. So this is how a data model is going to be. And I quickly want you guys to take your pencils or pen and a book right now, and please say yes if you've taken your pen and pencil. It's making it difficult to the lag. Okay, I'm assuming that you guys have taken your pens and notebooks. So yeah. So we're gonna find certain certain equations here where the transaction where a transaction of one product is affecting another product. So this is called as antecedent or consequent. Antecedent and consequent, where in the relation where A belongs, A gives B, A transfers B, A is the antecedent and B is consequent. It is pretty much like if and else. I mean, not if and else. Stage one, stage two. You can do that like that. And in this example, where people who buy diapers are likely to buy baby powder. So people who buy people who buy diapers are A, and people who buy baby powder are B. So people who are going to buy diapers are pretty much going to buy baby powder. That is what they're trying to say. So when they say that this directionality holds, we have to find the confidence. We have to find metrics to really prove this theory. So this is where discrete mathematics comes in, guys. So you have to be really strong with discrete mathematics also. Okay. So yeah, association rule mining uses the data as tuples. Tuples mean I think Ajay and Kailash have taught you about tuples. So let me not go there. And it uses transaction items in data model. So the one in the bottom you see, it's called as transaction items in data model. So it has different transactions in different rows and different products and different columns. So if I'm going to be transaction one, if I'm going to buy something, I have bought milk and bread and have not bought the rest of the items. So one on milk and butter, milk and bread, and rest three it's going to be 000. So similarly, it can be different person, different transactions. So yeah. Okay. So we have three metrics, guys. We have three metrics where association rule mining is defined. We are going to get into three metrics alone. We are going to look into support, confidence, and lift. So support is something where I say, hmm, so many people, like in this data set we have five transactions, and in these five transactions, three people out of five transactions, three people have bought bread. So in that connotation, it says that three on five, which is 60 percentage of people have brought transaction items at model. So it must be pretty popular. But that is proved with confidence. The confidence, it's going to say yes. With this annotation, we can say that so many thousands of people have bought it, and since they have bought it, they should have bought something else also with that. So support is, if you give them a hypothesis saying a person who bought bread has bought butter, it checks the support of how many people who bought bread, how many people who bought butter, and it's going to find a ratio in confidence by saying how, like, entirely of how good or how probabilistically people have bought in the bread and butter together. That is confidence. And lift is something which is going to give you a ratio of their correlation. From statistics, I think you should have got it. Correlation, if not, I'll explain now. Correlation is something where when there are two features here, such as milk and butter, you say milk and butter vary together. So if 10 people buy milk, they're also buying butter. So the number of people buying milk and number of people buying butter is equal. So it has a good variation, it has an equal relationship with it, and so it is equally correlated. So correlated in the name, as it says, it's related. It is correlated since it's two or three or four products or four factors or something. So yeah. And now this is where I need your books. So quickly plot down the formula for support, confidence, and lift, guys. We won't require affinity and leverage now. If you guys have plotted it down, please comment yes in the chat box. Lag is killing again. So yes, I believe you guys have taken the formula down. So yes, guys, we are gonna find support and confidence of these transactions that I tell you. First one is going to be diaper, beer, and milk. So the as the formula states, it is going to be you're gonna find support of these two components, where you're gonna find how diaper, beer, and milk covariate, and you're gonna find confidence. If you guys have made a calculation out of this, please do let me know. I've given you the formula. You have to plot it down, and if you get a confidence one, please reply one. Please reply yes. Somebody asked for a previous page. Okay. This is the transaction items and data model. So yeah. So diaper, beer here are going to be A, and milk is going to be B. So you are going to find the support of the co-occurrence of diaper, beer, milk with the total number of transactions. That is going to be your support, and your confidence. You're going to find support of both your diaper, beer, milk with the support of A, diaper, beer. So similarly, you'll have to find the transaction for these four things, and you'll have to, if your confidence is to one, you get a connotation that diaper is the most popular thing because it is there in all kinds of transactions there. So diaper occurrence is going to be very popular when milk and beer are bought together. So that is the kind of association that you're gonna find. So you're gonna find which item is popular and why is it popular. So with these information, this is one simple example in a transaction phase. We have a million transactions like that. Say if you're an OEM manufacturer, or if you're an automobile manufacturer or something, you're gonna see which car is bought, and when the car is bought, what all products are bought together. Or say if you were more into website again, if you're building a website, you can see which web page of the website is seen more, and uh, how it is propagated from one page to other. You can find all those metrics, and you can see what are the popular pages and how it is related, and you can make a way that people find those pages together. And only because of this market basket analysis, people in shops tend to place the items together. Like there are a lot of marketing movies coming out right now, but let me tell you, uh, what example. So yeah, if association between the three products are really good, you have to place all those together. So see, say if you're in some kind of a retail showroom where you're buying one pair of jeans, you tend to buy another. Like if you're buying one Levi's, you tend to buy some kind of other jean as well. So you keep all those products together. You keep the shirts together. You keep jeans and shirts together. You keep the jeans and the t-shirts together. So all of these matters on the data. It all depends on the data we have. So based on the data, we're gonna maintain a relationship. We're gonna find some relationship between them, and we're gonna place it accordingly. So this is where association rule mining comes in place. So we can use it in a lot of places, guys. And lift is gonna tell you if the events are going to be related or not. So if the lift value is more, it is going to tell you that the events are related more often than not. And if the lift value is lesser, then the confidence that the two transactions hold is going to be lesser. So you need not store them together in that aspect, or keep them or place them together. So we use something called as a priori algorithm, guys. A priori algorithm is a download closure algorithm. It does depth first search, meaning it gets into the branches. It gets into the branches first. It gets into the same level branches first, without getting into the next level branches, without getting into the leaf nodes. So yeah. So when your database has a transaction ID 100, 200, 300, 400, these are items that are bought. So we are gonna find one item set first. So one item set is where you find these items such as item 1, item 2, item 3, item 5, how many times it occurs in the database. Say 1 is found in 2 of the transactions. So that is why we put there support 2. And 2 occurs 3 times. That is why we put down 3. 3 occurs thrice, we put on 3, and 5 occurs thrice, we put on 3. We've not gone into 4 because we have, I haven't mentioned support here. Support is 2 here. The support threshold is supposed to be 2. That is why 4 is not here. So in future, like when we take into consideration, we won't start comparing 4 for any kind of relation. We're not going to say if beer is 4, we're not going to take beer with some kind of combination. We're not going to we're not going to compare some kind of item with a beer for a transaction. So in the item set, 1 3 1 4 1 3 4, we are done with the first item set, guys. We're moving on to second item set, where we're going to find co-occurrence of two products. So say there is a product 1, product 3. We are going to find how many times those product 1 and 3 are occurring. And with 1 and 4, I told you 4 can't come first, but it can come second. So we're gonna check if 4 is there. We're gonna find if 1 and 4 are occurring more than twice. It is not, and hence it is not starred. And by meaning starred, it is going to next transaction. Or you're gonna take that transaction to consideration for your next generation of item set calculation. And 3 4, it occurs once. So the support is 2 and it is lesser than the threshold, so we're not taking that to the next transaction. And 2 3 occurs twice, and it is equal to the threshold, and we are taking it to the next transaction. 2 5 is also greater than the threshold, 3 5 is also greater. 1 2 and 1 5, they occur only once together, and hence they are lesser than the threshold support, and we don't take that to the next iteration. So in the next iteration, we go with 1 3 4 2 3 5 1 3 5. So yeah, so we are going here. We are going to next position, where we find the co-occurrence of product 1 3 4 2 3 5 and 1 3 5, and out of that we find only one product which is going to be occurring more. So this is a priori algorithm, where you find the co-occurrence more, and this is the third item set, and you stop here because there is only one transaction you have to consider for three item set, and hence we stop here. We can't split that. We can't go for a four item set, because there is only one transaction there is only one item set that we've chosen in this position of spectacle. So yeah, a priori algorithm usually tends to use a lot of compute, case. It uses a lot of RAM. It does a lot of iterations. So that is not computationally feasible, and space complexity is too much for this algorithm. But we tend to use this. So if we are clear with a priori, we can go to the next segment. You can comment yes if we have to go to the next topic. Okay, I'm assuming it is done. So yeah, this is an interesting example that I left out. So yeah. So in 2004 in Florida, there was one hurricane, right? There was one hurricane where the rare item set was not found, where they found a rare combination of two products bought together. So they, with their item set, they found one specific thing bought more compared to other things. So they were very doubtful of their prediction, of their relation, but they were not wrong. So there's an example where you can refer to this example later. I don't think I have time to do this, but there's an interesting example where people bought strawberry tarts before hurricane in Florida, and because that doesn't require any refrigeration, or it doesn't require to be cooked, and they didn't know how long the hurricane would last, and they wanted to keep their tummies fulfilled. So they just bought hurricane I mean strawberry pop tarts more compared to other items. So yeah, so it does take a lot of time to run. Yeah, I think I've completed pretty much all of it in a priori. So we are moving on to clustering. So in clustering, we have something called as we have different data points with no label, meaning we had apple, orange, mango, or we have all these pineapple examples where it is not labeled according to their class. So we just tell the computer to find the patterns between the data and group it accordingly. So this is one such thing where the computer segments the data. Computer is going to find insights in the data. It is going to group the values, group the data points based on some specificity or some sensitivity in the data. It sees all the summary statistics, and it goes through those stats, and it is going to group the data. So yeah. So there are measures for finding the distance between there are measures to group data together, and it is done using these three metrics. These are done using these three metrics such as similarity, dissimilarity, and distance. And distance is Euclidean distance, guys. Assume you guys are in your home, in your room. You can find one, or you can find some kind of object near you. Just try measuring yourself with that object. I'm pretty sure you'll be confused how to measure yourself with the object. You don't know where, you don't know from which part of your body to compare with the object, because the object size is going to be different and your size is going to be different. You just would be wondering how you're going to do that. And for this very purpose, the data should be scaled, and data should be scaled in such a way that there is not much difference. The size shouldn't be taken into consideration. You should look into third dimension, or you should normalize the values according to the factors, and you're gonna make a comparison based on that. So like you are gonna be in some point in a three-dimensional world. You're just gonna be a point. You're gonna be a data point, and it can be your body mass, which can be your data point. It can be the bottle's body mass. It can be the bottle's center of gravity, your center of gravity. With those 2 points, you can measure. So it is something like that. Like if you have different scales of values of different objects, it is going to be very difficult for you to measure it. So you have to always scale your data, and in this aspect of clustering, scaling is really really important, right? Because if not for scaling, you can't measure proper distance, and you're gonna get different values each time, more often than not. So you have to scale the data here. So these are certain metrics where you can find distance. Euclidean distance is one, and we have some other distance called as Govar distance, which is used in multiple dimensions. And we're not gonna go into Govar distance. We're gonna stick to Euclidean distance today. I'm pretty sure you guys would have known Euclidean distance from your mathematics papers that you've had. And if you're first years, you would have done this in your school. Euclidean distance would have happened in your school, where you're gonna find distances between 2 points based on their coordinates. So that is pretty much it. And cosine similarity is where you find similarity between two vectors. So if you guys are really familiar with linear algebra, you would know it. And cosine similarity is something where, say, in NLP, when you have to find similarity between two words such as good, nice, you have to find their word vectors, and the word is going to be translated to embeddings in the sense numbers. Word is being represented to numbers, and those numbers are compared with their similarity, and with this similarity value you're gonna find if the two words are nearer in similarity. So this similarity can be used in a lot of places where you're gonna find sentiments. If you're gonna see the sentiments in the tweets of any person, like not just tweets, in any other aspect, in any kind of word, any kind of textual data, you can find coefficient similarity. But only thing is that you have to convert the textual value to a numerical embedding. And this SMC, Jacquard, and Dice, these three are dissimilarity measures, guys. So SMC is where I think I can give a better example. Right? It should be something. Yeah, here in dissimilarity, you're gonna decode the value of three different transactions. Say first transaction is going to be written as 100, and second transaction is going to be written as 010. Third transaction is going to be 001. So it can be represented in binary, and P and Q are going to be the two values where these are going to be measured. And simple matching coefficient is going to find the M01 value, which is going to be number of attributes like P0 and Q1, and the next one 10 is going to be P1 and Q0, and these 1000 values are going to be the values of P and Q. So you're gonna find 01 in the sense you're gonna find the positions where P is 0 and Q is 1. So there are only two positions where P is 0, P's value is 0 and Q value is 1. And you're gonna find different values where P is 1 and Q is 0. That is going to be 1. And you're gonna find the attributes where P is 0 and Q is 0. That is going to be 1, 2, 3, 4, 5, 6, 7. And you're gonna find where there is 1 where you can't find anything. So simple matching coefficient is going to find these three are going to take these metrics, and it is going to calculate your coefficients. And based on those coefficients, you're gonna find the distance between the two words. Say distance, like finding the distance between the two strings. So say sad, sat, SAT, SAD. So there is going to be difference in one letter, and that letter is going to be the measure of dissimilarity. It is going to give you the dissimilarity value index of a text or of a string, of two strings. So you can find dissimilarity and you can cluster the words based on the dissimilarity values, or based on the distance calculated using dissimilarity value. And here I'm going back to distance, guys. Here these are two kinds of distances that you can calculate: Euclidean and Govar. And these are certain transaction tables. I mean, these are certain tables where data points are plotted. So you can, as you see in the columns, guys, age in the first thing is mentioned in years. In second, it is mentioned in centimeters. So when it is measured in years and centimeters, it is not in common convention. So as your SI unit says, like not just the SI unit. Wait, yeah, as your SI unit says, if you're gonna compare it, it is going to give you values that A and B are close and C and D are close. And if you're going to convert your height to feet, A and C are close and B and D are close. And after you scale it, you really understand that none of them are close. So scaling plays a really, really big aspect, really big role in clustering, guys. When you have to group three or four, when you have to group two or three data points, you have to find the distance between the data points, and then you have to combine them together in a group. You have to put them in a group. So that is done with the example of scaling. I've shown the importance of scaling here in the example. So scaling is very, very important in any kind of data. Else you're gonna get all wrong results. And yeah, there is a pretty much a different. I mean, this is the same example that I gave you for clustering. I mean, similarity and dissimilarity. I've just taught you. And here, yeah, I'm going ahead with the k-means clustering. So k-means clustering is going to say k in this k-means clustering is going to say you the number of clusters that you're gonna get out of the data point, and means is going to tell you the average values in a group of data points. So yeah, so if there are 12 data points, when you plot these data points, you see that you can find three clusters. So if you can find three clusters here, if you can see three different groups, if you think you can find three different groups here, you have to directly go with k equal to 3. Okay, but we are gonna check with k equal to 1, meaning one cluster. For one cluster, different data points across the same line segment will give you a huge variance. Variance in the sense, variance between the data points. Okay, between the, you can say it as, if you guys know standard deviation, if you guys know standard deviation, you pretty much know variance. So you can say how largely separated the data points are. So if there are going to be two different clusters, you can find four in one cluster and eight in other. So for the second value, the variation is going to be huge. So you have to reduce variation, right? So you're gonna make another cluster here. So with cluster 3, your variation is going to be almost similar, almost equal. So your best variation, your best matrix is going to be with k equal to 3, and with k equal to 4, your cluster is going to be much lesser. So you're gonna find the optimum number of clusters that you're gonna get out of a data point using an elbow chart here. So you can see the reduction in variance. Like variance plays a huge part in clustering, guys. So after I increase k equal to 3, after I increase k equal to 3 to k equal to 4, you can see that the variance hasn't gone very low in the elbow chart. So you have to find the point where the variance starts reducing lesser compared to the previous things. So here you can find the staunch difference in the variation from a second cluster, from third cluster to fourth cluster. So from third cluster to fourth cluster, it's going to be your local minima, but your global minima lies in 3. So that is going to be your point of inflection, or that is going to be your optimal number of clusters. So I think you guys have understood the crux of it. Yeah. So we are going to k-means algorithm, and in k-means algorithm, first what it does is it is going to find random data points in the data. So these are data points, guys. So I've chosen k equal to 3. So my computer specifies three random data points here. Here you can find 1, 2, 3, and it is going to find its nearest clusters. So what it is going to do is, these three are called centroids, and it is going to find data points. It is going to group the data points near the clusters, and it is going to find the means. Mean in the sense, average between the data points, average of all the data points. So you can see here for the red thing, it is going to be average is going to be really less, and for the green thing, you can find that the average is going to be really high, because the values are much higher, and it has a lot of value, lot of data points, so the average is going to be really higher. And for the second iteration, you can see the centroids are repositioning itself. So the centroids will reposition itself based on the mean values. To reduce the difference in the mean values, the centroids reposition itself, and it is going to keep going to different. It is going to keep moving across the data until it finds an optimum value. So that optimum value is going to be your what do I say? It's going to be your variance value. So in the iteration one example, your variance is going to be really high. In the iteration 2 example, your variation is going to be like it's going to be really different between three clusters. And 3, it is going to be okay, all right, it is going to be just fine. And in fourth iteration, it repositions itself, and it finds the mean between them. Oh, sorry, I was all the while telling variance instead of mean. So it is going to find the mean value, and it is going to, like, okay, let me repeat it from the beginning. So iteration 1, you have 3 centroid points, where the data points you have to find mean between the data points, and you have to find a value of mean. And based on the difference in the mean values, the centroids are going to realign itself in the data. And in the second iteration, you can find that the centroids are realigned here. I hope you can find my cursor, and these three are centroid values. So yeah. And in iteration 3, the centroids are further aligned, further gone, further moved, and you're gonna find different mean here. And it's still a large spread. You're still not getting good mean value. And in iteration 4, you're gonna again realign the cluster centroids, because the mean value is still not optimum. In iteration 5, it has the in the blue cluster, you can see that the centroid has moved over here. It has moved. So you can see that the centroid point has moved, and has found another mean. And in sixth iteration, you find that the centroid has not moved from the position. So that is where the computer learns by itself, meaning it is going to find the average value there, and it is going to say, I'm not moving anymore, and it's going to stay there. So yeah, as the algorithm states, the centroid value keeps moving. It keeps finding mean values at different positions, and it readjusts itself to lessen the mean to make the mean value almost similar to different clusters. So yeah, this is pretty much the algorithm, guys. And there is another iteration. There is another example where you can find red, blue, and green. In the second iteration, you're gonna find it in the same place. Third iteration, it's in the same place. Fourth, sixth iteration, it's in the same place again. But you can see the data points that it's going to map. So that means in the picture it is in the same place, but technically it is somewhere around. It's going to make minor progress, minor movement, such that all the data points are converged. So for this algorithm, it goes until ninth iteration here for this example, until it converges. So when I say it converges, the means of different clusters aren't going to be having a huge gap. They are going to be almost similar, and that is when they stop. And you can stop the algorithm if you give a threshold value. That's going to be your approach. And yes, the these are going to be the, what to say, the limitations of k-means algorithm. Yeah, I think you guys should have known about convex algorithms. If not, I'll explain you now. Convex algorithms are those where you have multiple minimums, and you don't have just one global minimum. So in such positions, in such data points, in such data spread, uh, you tend to find clusters like these. In the second picture, where you find green and blue graph, you have cluster within a cluster. So that is going to be separated using an algorithm called hierarchical cluster. So hierarchical cluster is another kind of clustering which is going to find the relationship between the different cluster data points, and it is going to differentiate. It is going to branch the data points into different positions. So here, using hierarchical clustering, you can see that there is a clear difference in the positioning of green and blue data points, and that is the divide. So it doesn't, like, one data point doesn't lie within the other data point. So yeah. And the other example, since this algorithm is going to randomly position itself with the centroid points, you can get different outputs as well. Different output in like, since the starting position is different, the data points you map for the first time, and for the data points when you run for the second time may vary, or it will vary. As you see in this algorithm, as you see in this example, the blue and green points here, the blue and green clusters here are nearer, and this is entirely taken as black, the black cluster. But in the second picture, you find that blue, yellow, black, and all these clusters are placed distant. So this is because since we use random initialization of the centroid points, since this algorithm uses random initialization of the centroid points, you tend to get different outputs for different initialization. So yeah, so I'll give you guys. So these are different clustering algorithms. You can I'm going with K-means algorithm today, and this is just an introduction session. I pretty much think you guys will get into machine learning post this, and I think you guys will explore all of these. But here is an example slide for all of the clusters available. Right. So yeah. So I think you guys can take a sip of your water from your bottle, and I'll give you some 2 minutes break. So I assume you guys have taken a sip of water from your bottles, and yeah. So supervised learning. Supervised learning is something where you tell the computer, from the Apple example again. Sorry to go back there again. You have different fruits with you, and you find difference between these fruits, and you're gonna classify it. You're gonna classify it as apple one, mango two, or pineapple three. So with those values, you have your data where it is labeled. Your data points are labeled, meaning they have a target variable. They have a column stating that it can refer to the previous. When your algorithm runs, your trained data will have an output value, and it has a target value, and it is going to learn from the historical data when you're going to put in new data to the model to learn from it. So supervised learning is a machine learning task of learning of a function that maps an input to an output based on example input output pairs. Yeah. So the data points there will be like input output pairs, right? So input output pairs, in the sense, you have your data points and your labels. So yeah. So supervised learning is divided into two parts, naming uh, regression and classification. Regression is where, okay, I'll pretty much move on to the next slide. So I'll give you the examples of classification and regression. Classification and regression. Classification is something where you're gonna label an object or label something based on the historical data. It is going to be a discrete value, something like predicting the roll of a die, or something like something with the probability of an event happening, or something where you can predict if RCB can win, something like that. And regression, yeah, regression is going to be a value. Regression is going to predict continuous variables. So it's going to predict continuous values with a label of continuous target variables, stating you can predict you can forecast the weather, which is not going to be 1 2 or 3, which is not going to be uh, within any class. When it's going to be the temperature, if it's 10 degrees today, it's going to be 20 degrees tomorrow, it's going to be 30 degrees tomorrow. So it can vary, so that is going to be continuous variable. So if it can be 21.4, 21.5, so it is a continuous variable. So you're gonna predict the values rather than the labels. So if I can tell you properly, classification is an algorithm where is a topic where you can associate a data point to its target label. If you are going to find if a weather is going to be hot or cold, then it is going to be classification. Hot is a class, cold is a class. But if you're going to find if if an if a data point, or if you're going to find the temperature of tomorrow or day after tomorrow, if you're going to forecast weather, it is going to be 21.4 or 21.5. It is not pertaining to any class. You're going to find the value. So the values are going, if you're going to predict a value, it's going to be regression. So you have accuracy metrics for classification, such as precision recall, confusion matrix, evaluation metrics. You're gonna train your model. You're going to evaluate your model using your validation data or your test data, and using your observed and predicted values. Observed values is something where when you're going to have a data set, you're going to split it using test, train, and all that. And if you're going to do that test and train split, you already know your test values in your data set, but you are removing it for your convenience to check the model's accuracy or check the prediction to see the performance of your model. So that is how you can find the difference between the observed value and predicted value, and can find the loss value or accuracy from that. And for regression, you're going to find the same observed or predicted values, and you're going to find the mean square root error of it. And mean square root errors are going to be huge. That is why we incorporate something called as root mean square, which is going to be RMS. Yeah. So I'm going with regression, guys. As I've explained to you, regression can be used in predicting housing prices. It can be used in predicting distances, like when you use Google Maps, or it can be used in finding temperature, predicting temperature and numbers, or you can find the numbers of the cases for corona as well. You can actually forecast that, and you never know if it's true or not. But yeah, and the types, there are few regression algorithms, and I'm going to stick to linear regression and multiple linear regression. But you can actually look into decision tree regression and random forest regression as well. So these are certain regression algorithms. uh, Linear regression is going to be your y is equal to mx plus c classic line formula. So let us get into that. And classification is supervised learning, and binomial is going to be your binary classification. So if it's going to be yes or no prediction, if it's going to be cat or dog prediction, then it is going to be then it's going to be supervised then it's going to be binomial supervised learning. If it's going to be multiple class prediction, if you're going to find it between dogs, cats, and pandas, it is going to be multiple classification. So yeah. So a few examples of class for classification is spam or ham, or when you find bank loan, or if you can find if a kid will pass or fail an exam, or and facial recognition is a very good example of classification as well. And I think you guys can know the difference between linear and non-linear models. Linear models is going to be a straight line. It's going to be a line, and when you plot it in a graph, like when you see in the petal sepal example, it is divided using a line. And and non-linear models usually tend to use multiple dimensions for measuring their values. So that is going to be non-linear. It's not going to be a line that is separating. Yeah, we are getting into the crux of regression algorithms, and we are only covering the basic algorithms today. So yeah. So linear regression is a statistic model used to predict the relationship between independent and dependent variables by examining two factors. Or so here, linear regression is going to predict you. It is going to take in. It is going to predict some specific thing. Some specific thing in the sense you can predict the cost of your houses based on the locality, based on the time, based on you can predict the stocks of stock market predict. You can do stock market prediction where you can find the price of each stock. So each stock's price is given with its date, and you're gonna simply go with factors such as crude trade. You're gonna go with factors such as what do I say? Hmm, export cost, import cost, and all that. And with that, you're gonna draw a regression line, and you're gonna find the values or cost where the cost of the stock, how it's going to move with corresponding to the date or with the number of days you foresee that. And if you guys know, crude's price has dropped tragically because of this quarantine, and a lot of industries are getting affected. So it's high time you guys learn about stocks now. If you can invest right now, you're gonna be market leaders in some time. So yeah, you guys will have known y is equal to mx plus c from your analytical geometry from your school. So where m is your slope and v is your y-intercept. So slope is nothing but the line where you see in this graph where you have this b to 1 unit, right? That position of that is going to give you the slope of the line. That is going to give you how skewed the line is going to be in the data. And b is going to be a y-intercept stating the position, the number of points, the distance from the origin line or the x variable line or zeroth position of y, number of points the intercept line or the regression line is going to be far from the origin. So that is going to be your y-intercept. So your dependent variable is something you're gonna wait. Dependent variable is something that is going to influence, that is going to take in a lot of variables into its account and going to be there. And dependent variable in our position, in our thing called as the stock market, dependent variable is going to be your cost or the stock price. And in the position in the same example, your independent variables are going to be something like your GDP or something like your import cost, something like your export cost, something like the dollar rate, something like the crude rate, and all that. It's going to affect the stock prices, stock market prices of each company. So those are indirect factors that affect the company, which are related, but they don't influence each other directly. So yeah. So this is linear regression example, guys. You're just gonna plot the data points and you're gonna find the best fit line. If you're gonna plot the data points if you're gonna take some data such as your online advertising sales, where you spend $1.7, like $1.7 in and you get 368 sales and $1.5, these are going to be your x and y coordinates. And online advertising is going to be your x value, that is going to be your independent variable. Online advertising is one of the factors that your sales are going to happen. That is not the entire attribute that is going to account to the sales. So sales is going to be accounted, sales is going to be dependent on a lot of features such as inventory cost, production, warehousing, marketing. And in marketing you can find advertising. So advertising is an independent variable, and the sales is going to be a dependent variable for all these factors. So for so in your graph, your x should be advertising dollars, advertising thing, and in your y it should be your sales. So we have plotted a certain points, and we've drawn a line, the orange line there. That is going to be your regression line. So how we find the regression line using we plotted using our formula y or y equal to mx plus c. So that is pretty much there. And I want you guys to just find the slope of these points, these data points. And I'll wait until you guys give me a slope. You can do it using you can do it using the slope formula y2 minus y1 by x2 minus x1. With this formula, I want you guys to find slope of each value, entire slope calculated together. I'll wait for you guys. So guys, Andrew NG, Sathvik fan 1, Sathvik fan 2 are your passed out seniors, so just ignore that. Guys, it's right out there. You can find the slope in the screen. If you can just point to that value, if you can type it on the chat, I can just move on from here. So I think I can move on from here. So guys, a quick update. I think I require your additional 20 minutes because of an initial lag. I'm really sorry for the inconvenience. And if you're really interested, please say yes on the comment so that I can move on. And I found an interesting question: logistic regression. Logistic regression isn't a regression example. That is going to be your classification example. As like it has regression in its name, but it has logit in that. So logit is going to be 0 or 1. It's going to be using a sigmoid function there. So it can't be used for stock prediction. So yeah. So yeah, guys. So yes, in this example, 171.5 is the slope value and 125.8 is going to be your y-intercept. So with the slope and the intercept values, you can very much predict your y value for the future values. So when you spend $2 or $3, three advertising dollars, you'll know how much it's going to affect your sale, how much it's going to improve your sales or affect your sales with the regression line. So yeah, that's pretty much it. So there's multiple linear regression. So in the previous example, we were doing it with just one. What do we say? We're just using one independent variable. So we here take multiple independent variables, and we are going to predict it with different axes. We have three axes here, and we are going to find a relationship between the three axes such that it's going to give you a line or a plane that is going to separate your three-dimensional space, and you can find your classification along the line. I mean, you can find your regression plane along the line. So this is known as a hyperplane. Hyperplane is something that is going to separate your three-dimensional space. So you can find your values with this plane structure, and similar to that, we have different weights here in this equation, and with different weights and different values, we are going to find different predicted. I mean, regressed values here for different sales. So if you're planning to use not just say if you're planning to in this example, if you're going to use something apart from the advertising dollars, like your supply chain time or your production time, that is going to be giving you a much better insight on your sales. So multiple linear regression can be used when a lot of explanatory variables are there, so that you can find the relationship between them and you can find the correct best fit line in that. So yeah. And these are a bunch of classification algorithms that I'm going to get into right now. So here, as someone stated, logistic regression is not on slides. I'll just give you a quick update on logistic regression. Logistic regression is something that is that is going to be that is going to predict you either 1 or 0 from your trained data. So you have something called a sigmoid function. Sigmoid is a log based function which is going to take your numerical values, continuous values, and it's going to give you 0 or 1 outputs. So 0 or 1 outputs are in the probability space, probability outputs. So you're going to find the probability values and you're going to classify it based on the probabilities and put it in a class. So logistic regression is a type of a regression algorithm that is used for classification. So the only tweaking here from regression is regression uses a straight line, but here we have a S-shaped curve with sigmoid function. So it's going to be probabilities here. So that is why we can't use that for stock prediction. And in non-linear models, we have I mean, in support vector machines is something where we use the concepts like hyperplane. We have multiple dimensions. We are going to separate if we are dealing with two dimensional values. We are going to add an additional dimension. We are going to separate the dimension from one dimension, and we are going to find a proper plane that is going to separate the values, so that you can find difference between them. So SVM can be used pretty much in a lot of cases. SVM is actually one of the best algorithms that we've used, but one thing is it is very heavy. So SVMs are used, but it is quite heavy. And in non-linear models, we just went through k means, but there is something known as k nearest neighbors. So as similar to that, there we had centroid points. Here we have centroid points, and we didn't have the labels in k-means algorithm, whereas here we have the labels, and based on the labels you have a centroid point, and we will find the distance between this distance according to the centroid point from each data point, and we are going to classify them in groups again here, and we are going to find the group based on the labels. I pretty much confused all of you, so I'll just repeat. K nearest neighbors is a classification algorithm where you have a bunch of data points and you have a target variable also, and the target variable will be plotted in the graph, and with the help of the target variable you're going to repeatedly find the distance between the data points with respect to the target variables, and it will be labeled with a metric of distance from the target variable. So yeah. And kernel support vector machines is it is going to kernel is something which has three dimensions. Again, it's going to give you multiple dimensions. It's going to separate a plane. So this is going to be non-linear. Support vector machines which are linear it's going to deal with single dimensions. So I pretty much covered kernel support vector machines also in support vector machines. In naive bias, as the name says, it's very naive. It is going to run on basis of conditional probability of Bayesian theorem, Bayesian probability. So we are going to cover naive bias here, and I didn't think we had time for decision tree classification, so I'm not going into that. But decision tree classification is something where you get your factors, and based on your factors your tree branches, and it's going to find the nearest approximated value based on the factors. So say if you have six factors stating, if you have to find if a person likes a butterfly, you look into the person's, I mean, you see if the person likes a color, you see if a person likes nature, you see if a person likes animal, and based on, I mean, insects, and based on those weighted values, you're going to find the closest approximation, so that your data points branch, and they find you a class where you can approximate it to one place where you find if the, I mean, if the person likes a butterfly or not. So you can do that. There's a classic Kaggle competition for data, I mean, Titanic survival. So you have to find if a person has survived from the Titanic disaster. So you can find that using decision tree classifier with the factors you have in the Kaggle data set. So yeah, random forest is, as the name suggests, it's very random. It is not that interpretable. It like interpretability is something. When you build a model, it gives you an output, and you have to explain how it is given you the output. In random forest, the explainability is much lesser. It is a bagging algorithm, meaning it takes too many trees into it. It constructs multiple decision tree classifications. It's going to bag all of them together. It is going to find the highest, it's going to find the tree which is going to give you highest value, highest approximation, and lesser loss. So random forest is very difficult for interpretability. You can't say which tree it has chosen. You can't say how it has chosen that. It varies from a training data set from time to time. But in decision tree classification, it is very interpretable. So as and when you narrow down a feature, so if you say if the person likes a butterfly, you're going through the first feature, right? If he likes an insect, so you have conquered that part. So you're gonna draw a straight line or a vertical line or a horizontal line based on the person's interest. So you're gonna draw lines, and then you're gonna draw sub boundaries between the lines. So if a person is going to give you x and y coordinates, you can pretty much plot it on a map and say it is going to fall in that axis. But that doesn't happen necessarily in random forest classification. So yeah. So knife buyers, as I've told. So here we are coming to the classic example of apple, red, round, and texture. Red, round, and inches. So these three are going to be your independent variables. So in like you have your color, you have your texture, you have your size, and with that you're going to find if it's an apple or not. You have a target variable already. So what this algorithm does is it's going to find posterior probability. Posterior probability is something that is going to give you wait posterior probability is something that is going to give you a conditional probability, that is going to tell you a probability of an event occurring with the set of other variables. So you have features such as weather. You have features such as uh, pitch conditions and all of that, to see if a person, if a person can play that day, if a cricket match can happen that day. So all you're gonna find if the cricket match is happening or not on that day based on the variables such as the weather and the pitch conditions, with the predictor probability such as p of x. P of x is going to be one of your independent variables. So yeah, class probability is again, it says how it gives the probability of a class with the trained data set. Class in the sense if the match is going to happen or not, zero or one. So all those class probability in the sense it's going to give in ratios. It's not going to be zero or one. So with those ratios, you're going to add that to likelihood, and you're going to put that to predictor probability, and you're going to find the posterior probability. I just want you guys to take this formula up on your notebooks. We are going to do an example. And if you're done with taking that up, you can comment, guys. So I assume you've taken this up on your notebooks. So this is an example where you're gonna see if a person or a match can happen based on the weather condition. So we are gonna plot it down. Here is the I've given you the formula. So this is going to be your value set. So based on this, I want you guys to calculate this by your own before seeing the next slide, because next slide has the value. You just have to like segregate the data. You have to make the data you have to like find the likelihood of the data, likelihood table. You have to find the probabilities of event happening, or you have to find the probabilities of the weather conditions with the event happening. That is conditional probability or joint probability. You have to find all of that, and with that you have to find the values. So say if I'm going to see uh, if I'm going to find a probability, say if I'm going to give a connotation where it is sunny, they're going to play. So they're going to play if it's going to be sunny. So you take into probabilities such as it is going to be sunny if they're playing one. So yeah, if the players are playing, it is going to be sunny. That's one. Take like assume it is a test match, and number two, the play is happening. That is going to be your class probability. So all these are calculated from your likelihood table. And for if the for you if you have to find the probability of the event happening, if the given condition is sunny, you're going to have to find the probability of the weather as well. So higher the probability, higher will be the chances for them to play. So the probability, as and when the probability is higher, the probability variable is higher, your chances to play or chances for an event to occur is going to be higher. So yeah, I want you guys to take this frequency table and likelihood table, because this is very important. Or you can find it on internet. That is pretty much there. I don't want to eat your time up. We still have 8 minutes. And real-time applications of naive Bayes. So yeah, real-time prediction in the sense naive Bayes is very light, guys. Naive Bayes is very light, such that you can run any kind of predictor algorithm. And so if you're not so focused on the prediction probability, or prediction accuracy, you can go with naive Bayes. That is very very simple and very very light. So you can obviously use that. And for multi-class prediction, yes, we can actually use that for multiple classes prediction. Like here in the previous example, we just did it for one I mean binomial classification, but we pretty much can use that for multiple classes as well, such as finding cat, dog, rat, or something in the case of image recognition. And in you can use that in text classification, where like in sentiment analysis based on the tweets, you can based on the tweets or based on the data, you can see if the tweet is going to be sensitive, that you can find if the tweet is hate speech, you can find if the tweet is it's going to be emotional one. You can find all of that using naive Bayes itself. So sentiment analysis is one good example of that. And you can do spam filtering with this. Spam filtering can be used, it can be done using a lot of algorithms in supervised. So yeah, you can take that as an example for anything. And in recommendation system in the sense, you can take the classic this thing Netflix recommendation itself. It can you can actually take in the data. You can find if a person is going to watch the show, given if the person is going to watch The Witcher, given they watched Game of Thrones. Those two shows are similar. So you can actually find connotations like that. So yeah, so nearby application is done. And I just want to give you guys like a small introduction on deep learning. And I would just want to give you like the difference between both of them. Like it is not actually a difference, but machine learning is something where you extract features for the model, and then you give it for a car, you give it for a classification, and you get a model out of it. I mean, you get a prediction out of it. But in most of the cases in deep learning, the feature extraction stage is also done in the neural networks. And that is pretty much in the hidden layer. In the input layer, you'll be giving your input, and in the hidden layers, the input is taken, the feature is extracted, and the classification is done. So based on the feature extracted and based on the classification, your output will be given. And based on the trained data, your accuracy will be known. The higher the data, higher the accuracy will be. So, and not for all algorithms, not for all cases, but you'll reach a certain point where how much ever the data you enter, the loss function will be at its minimum because it's going to be global minimum. So yeah. And neural networks is classic example. I don't think I have time for neural networks. I think it's pretty much the end of the session, but I'll just give you a gist of neural networks. Neural networks is a thing. Neural networks is loosely inspired from humans neuron architecture, neural architecture, where you have something called a neuron. Your nerves have all these activations, which your brain gives all these activations to your motor, your sensory controls using these neurons. Neurons is a unit that is going to pass message from one part of your body to another part of your body. So neurons are pretty much an information carrier or data carrier. So neuron is going to it's going to direct your computer to do certain tasks, like how a neuron in your human body is going to tell you to do certain things. So if you're sad, your brain's first intention is going to make you feel sad. So that is also a neurons information to your neurons information from your brain that is going to that's being passed to other aspects of your body. So that is pretty much the neural networks. But if I have to go in depth, I'll have to go all on and on. But I'll just give you a gist. So you have something called an activation function, you have something called cost function, you have something called as loss function, and you have lot of neural architectures. You can build a lot of neural architectures, and a lot of neural architectures are still in research as well. So for image recognition, most obvious example is image recognition, facial recognition, or video analytics, where in times of corona you can do this example actually, where you can find two people wearing masks, and you can find the distance between the two people wearing masks. That is going to be your project. That's going to be somebody's project for social distancing if it's going to last for a lot of like a long time. So that is going to be one good example. And the other thing, you can like a lot of people are getting caught in Chennai by not wearing helmets. That is a classic example of video analytics, and that is a classic example of how a neural network helps in video analytics. So they take in a lot of dependent variables. They take in a lot of variables such as like you give an input, such as an image. From the image, it's going to take out a lot of features such as it's the image's quality. First thing, then from the image you get the features such as your if you're giving a human face, it's going to find your color, your texture. It is going to find different patterns from the image. So all of that patterns you have to guide. So for the computers to understand something, you have to set in parameters, and with those parameters, the computers will understand. Not just the computers; it's going to be cyber physical systems. So all the machines are going to understand. So we're in a world where webcam and the computer is going to predict what kind of stuff you're doing. So that is surveillance. So maybe it can avoid watchmen also in future. So it is already avoiding. It is already removing a lot of stuff. So these are different types of neural networks. This is here because I thought you guys will be entertained, but I don't think I have time for that. And reinforcement learning, I'm just going to give you a gist of it, guys. Reinforcement learning is something when you're motivated more towards the goal. Like as in when you play chess, when you move a pawn, you see if it's getting killed by another pawn. If it's getting killed, you're going to come back. So that is one step of a learning for a computer, for a machine. And that is one example. So more and more it does, the more and more it learns by itself with more and more interactions with the real public or real environment, and it's going to heap in rewards. So yeah, that is pretty much reinforcement learning. Reinforcement learning, that is going to take a lot of time for all of us to do research on it. But if you're a beginner, please start with supervised learning, unsupervised learning, and post that you should get into neural network space. I wouldn't suggest you guys to directly jump into neural network space. I want you guys, if you're listening to this, if you think you want to get into machine learning, first thing that is more important is patience. Number two, it's going to be linear algebra. It's going to be your calculus. Calculus makes an important thing. It's an important part, and probability queuing theory, statistics. Those are all going to be one of the most important, that is the crux of neural networks. So that is going to be the most important aspect for somebody to build machine learning model. So it is roughly mathematics, guys. Like, you know, like the mathematics you learn from your first semester until sixth semester or seventh semester, you do it. Those all are going to stay with you till your lives end if you're going to get into machine learning. So if you like mathematics, machine learning is a cup of cake for you. I mean, it's a piece of cake for you. But if it's not, I'm sorry, I don't think it is for you. So yeah, I've pretty much come to the end of the session, and I'll take questions, and I'll take questions specifically from people who are not Sathvik fans and Andrew NG. So yeah, why is it called naive? As I told you, it's going to take in, it's going to make an assumptions. It's going to take the first prediction probability, and it's going to take that, it's going to calculate probabilities based on the data given, and it's going to give you the values from the independent variables directly. It's not getting into some kind of featuring or some kind of scaling in it. So that's going to be naive. It doesn't understand you. You're not going to make the computer understand the data probably. You're going to make it vague for it. It's going to give you a naive output for it. And mm, in unsupervised learning, what is the difference between clustering and association rules? Anusuya Narayanan. I think I've covered that. If not, association rules is going to find relationship between the data points, and clustering is going to find certain summary statistics in the data, and it's going to group the data points. It's going to find the cluster statistics. So yes. Okay, guys, that's been my time. Thank you so much. Thank you for your time, and thank you HPC ACM. Thank you Anita ma'am, and thank you everybody for giving me this opportunity. I think I've given you some insight on the data, and I think you can carry forward from here. Thank you so much, guys.